Stamitalks.
All right, welcome everybody to a new episode of Stamitalks. Today we're going to talk about revamping technology, and for that we have our guest Freddy. Welcome, Freddy.
Thank you, Mark.
Freddy Buitink, you are head of Evolve Sales, I think is your official job title. So it means head of the sales of revamping.
That's correct.
Can you, before we get into the revamping itself, like to learn a bit more about your background? Maybe can you share, how did you end up in the industry? How did you end up in Stamicarbon?
So suppose you're not starting with when I'm born, but
No,
you're more interested in when I started with work.
You can start with when you were born, but I'm not sure if you want to disclose that information.
Yeah, that's too long ago. I think people may lose track. So I started working for Stamicarbon, and now I'd have to say for DSM's Dutch State Mines, was the mother company of Stamicarbon at that time in 1986.
Okay.
And Stamicarbon I never heard about. In 1986, I started working in mechanical labs doing scale-up of chemicals products for DSM, as a worldwide company. But I heard about Stamicarbon a couple of years later by a colleague of me already working for Stamicarbon. And he said, Freddy, I think you'd like this company very much. It's very international oriented. So DSM was more like internal focused at that time, and Stamicarbon was selling the technology developed by DSM at that time.
Okay.
So I looked into Stamicarbon and it really got very attractive. So I put the vacancy in the ad, put the vacancy up, and I replied on the vacancy, and I got the first contract with Stamicarbon in September, the 1st of September 1990.
1990, okay.
And the 9th of September 1990, I was already on a site in India, in Kerala province, starting up as learning on the job, activities, separated from wife, which already was quite an endeavor.
And that time, that was probably a few months startup?
Yeah, at that time you have to remember there was no connection with the home front. In 1990, the connection was very poor. So I have to call my wife for 5 minutes in a week. It cost me about a lot of money to connecting. And you really have to wait a long time before you reply, otherwise you're completely out of sync.
Oh, okay. But that's almost 5 years ago. So since the experience gap. So then you started to work for Stamicarbon as, well, maybe training on the job, starting up a plant. Was it a urea plant already, or was it different technology?
That was a caprolactam unit. It was a couple of huge units. They have different sections, they call it, section 5, 6, and 7. And they developed at that time, had 2 plants in China. First plant was in India. I was already starting up. That was me learning on the job. And the second job in 1992, I had to commission one of the caprolactam plants in China.
Okay, so then how did you end up at the urea business?
And Stamicarbon sold a lot of licenses. Urea was one of them. And at the time I did my commissioning job, it was in 1992, 1993. My wife said, because I was for a year in China. So it was not really a good period to raise kids and family life. So my wife said, I think it's best you quit this kind of job because I don't see it happening, raising kids with you being away all the time.
Yeah.
So then I said, okay, let's switch to another job. And DSM, Stamicarbon, at that time offered me an engineering job in the melamine urea business, which I took up. That means still commissioning job, but much less so than pure commissioning job. So that's the reason I started to do the engineering in the urea plants. And at that time, DSM, or Stamicarbon, working for Stamicarbon, had the principle, if you really design the plant, you also have to commission the plant. So I designed a couple of plants and had the pleasure to also commission this plant.
Okay. You eat your own dog food.
Exactly. So, but I think it's very important that as an engineer, you not limit yourself to the drawing table, but also go in the field to see what you have done.
Yeah.
So you face the consequences of all your mistakes you make, but you learn a lot.
What were the, if you remember, I don't know, but key insights that you gained during that period?
The key insights is that there's a lot of details which makes the plant running. There's not only the main framework, but if you miss a detail, it also can hamper the plant.
Okay.
By one of the examples, for example, that we missed a certain dimension which limits the gas flow. And due to the limiting gas flow, the HP scrubber was blocking up all the time.
Okay.
But we couldn't figure out why. We had to open the equipment to figure out why. And only then we missed a small piece of low pressure piping, which was really hampering the thing. So we cut it out a little bit, and after that, it was solved.
Okay.
So then you notice, okay, you have to be very careful measuring and determining all the nitty-gritty details, which is important for functioning of the plant.
Okay. Is that also where your I'm going to call it love, I'm not sure if it's love, but your enthusiasm for revamping originated?
Yeah, I am a guy who likes challenges, to be honest. So if you do a couple of grassroots, which is more standard approach, is really proven concept what you normally work with. So it is really detailed out to the letter. There's a little variation because you do not want to risk anything. It's very secure design, so to make sure that the client exactly gets what he wants. Revamping business requires much more flexibility and creativity to make the best out of it, to make sure you cover everything. It's more complex, so that I really like. I like complex things. Some people like simple things. I like complex matters.
Okay.
Really get energy from solving it and troubleshooting. That's my passion.
Okay. So how does that start? Because of course you get approached by a client to say, well, then they're probably not going to reach out to you, say, well, hey, Freddy, I've got a complex challenge for you, but they probably will come to you with a specific need, which my guess is mostly a need for capacity increase. How does that work? How do you start?
We have two different approaches. One approach is what we call a passive acquisition. That means the client approaches us either with a problem, which we use to also teach the client what he can do as a additional to increase his revenues and his lowers emissions or energy. And sometimes we go out to the client and we analyze clients up front and say, okay, this client is operating the plant in such a way that I think there's a potential to get more of the plant, to increase his revenues or lower its cost. Then we visit the client, show him a principle of what we can do for that, show them also from client side what we expect the cost to be and the revenues would be, so he can do his own return of investment calculation to determine if the revamp would make sense for him, yes or no.
Okay, but then it's, of course, it's always a paper exercise, but I can imagine that if you sell a new plant, then I think the benefits are very clear. I think if you sell a revamp, then there's always a certain amount of uncertainty involved. There's more risk. So how do you convince a client of that, what you are telling him that's achievable, that it's realistic?
Now, I can give you a practical example. I had a client which had a fairly old plant, 800 metric tons per day plant, which he wants to revamp to 1,300 metric tons per day.
Mm-hmm.
And he wanted to do a revamp to minimize costs. So we investigated this option and we found out that, we can really do it by putting a lot of lines, doing modifications, adding 20 pieces of new equipment, and then slowly increase the capacity to 1,300 tons while still retaining the old equipment with its limitations and its issues. The client only asked us to do a revamp.
Mm-hmm.
But then I thought, okay, in this case, the client would be much more helped if he has a partly new plant. So part of the plant completely new, with only the rotating equipment being existing. Because that only requires 4 pieces of equipment, a hell of a lot less maintenance and electricity and energy consumption, while the investment cost was only 10% more than the whole revamp.
Okay.
So I presented the client, at the time that I did the study, I presented the client an example for, now we can do this.
Mm-hmm.
Of course, we can do that, and the cost is minimum, and we have minimized the investment, or we can scrap it, big part of it, and build just a complete new section that costs only 3 pieces of equipment and only 3 million more.
Okay.
The client looked at me and said, are you serious that this can be done? I said, I'm pretty serious that this can be done.
But then both for a total capacity of 1,300?
Yes.
Okay.
So the client just stopped the study and started directly with the project. So he didn't wait. And now its plant is in operation and the client is extremely happy of the decision made at that time.
Okay. So do you always start with a study like that?
Yes. And why do we do that? For a new plant, of course, you have no limitations. But if you have an existing plant, you have not only just a number of pieces of equipment, but you have the way the plant is operating.
Mm-hmm.
And sometimes it operates well and sometimes it does not operate well. So you cannot just get the drawings and draw it again. You have to really go to the plant and look at all the nitty-gritty details, the valves, emission levels, intake levels, production levels, to make sure that you do not miss anything if you do the revamp.
Mm-hmm.
Whereas the revamp, you add something to the plant, but the existing plant is still there. You can make a nice revamp, but the existing plant is not operating well or is not well matched with the revamp.
Yeah.
You as client, you will have a lot of problems. In the end, we also will have a problem, but the client is much more faced with the issue than we are. So Stamicarbon, we have a reputation to uphold, so we make sure that the design is as best as we can make it for that client.
Okay. But then, you say that there's lots of nitty-gritty stuff. You mentioned as an example the quality of a valve, or if a valve opens or closes easy or not. I think it takes quite some time to investigate a whole plant if you go into that level of detail. Would it be just easier to, just build a new plant?
Easy it will be. But if you look at the cost perspective, you can imagine you have a 2,000 metric tons per day plant, but you want 1,000 tons per day more.
So from 2,000 to 3,000.
You can build a new 1,000 metric tons per day plant on a separate location and build it there. But then you don't make use of the existing equipment already in place, like compressor pumps, and so you have to build everything from scratch. So in our experience, a new plant, additional capacity of a new plant makes life a little bit simpler for that side, but it will cost twice as much as a revamp using maximum margins you have the existing plant.
Wow. Okay. So, but then it's this study becomes more important, so you do more work upfront. So just for my reference, how long do you? Well, of course, a small plant is different than a completely big plant, but such a study, do you need weeks, months, years? How long do you need for such a project?
It depends indeed what you say, a little bit on the scope. We call it the scope. We'll go, what does the client really want? Wants the only capacity increase, combine it with an energy revamp, or only an energy revamp, or an emission revamp. We look at the level of engineering we require to get a successful project, and that determines the price and the time it takes.
Okay. But it's so if it's the most simple version of a revamp, it probably, my guesstimate is a month, I don't know, up until,
4 months, 5 months.
Okay.
Because you have to remember, revamp is complex and you want to make a success. Because if you do the revamp, it's not only important that the revamp works well, the additional one, but also the existing plant would still be able to run smoothly. So you have to also look in the connections between these two and alignment of the existing plant with the new plant. And there's the knowledge looking for, because you really have to know what you're doing. You have to really compare each line, each flow to make sure that you not miss anything.
Okay. Do you know examples of things, projects that where something was missed or something didn't end up well?
Normally we meet all our targets, but again, Stamicarbon is responsible for the engineering, the principal engineering. We are not responsible for detailed and basic engineering. For example, Stamicarbon checks all the process requirements, process lines, take out, but utilities is typically just specify what we need, and the contractor is supposed to pick it up and make sure we have it.
Okay.
So in one of the clients we designed the plant, and we started up the plant, and the plant was not performing as you would have expected.
Okay.
And then you have the issue. Okay, what is the problem? Where is the problem? Is it in our design? Is it the contractor's design? Is it at the client side? How do you find out? That it took a lot of time to evaluate what the issue was. In this case, the issue was the lack of supply of cooling water to a certain condenser, which backs up the whole issues to the rest of the plant.
Okay. And then the result of this was a decreased or not meeting the expected capacity?
In this case, the emission limitation was the cause. But in this case, we could not meet the emission limitation because the pressure was too high, so they had to vent even more instead of less. So
okay.
It was really an issue. In the end, we have to reduce the capacity to be able to meet the guarantees. In the end, the client has to step in and to make even bypasses to compensate it. Now, in the meantime, we are going to solve these cooling water issues. And once it is solved, we get the plant back in operation as we would have done. But this is an example of what can go wrong. Of course, we have warned the client up front that there is a risk that you have a higher demand on steam and cooling water. And we propose a design where you have a lower demand on steam and cooling water, so you don't have to be concerned about it. So staff of Stamicarbon is only to check its equipment what he designed. It's not our task to check the cooling water.
Yeah.
But in this situation, it would be better if you would have been involved from all the phases. So then we would have identified already that the cooling water was not sufficient, and that would have caused this kind of problem could have mitigated before.
Yeah. So then the project takes extra time, extra investments, and
It's always the case. If you want to do good work, you can make sharp corners, and save cost on that kind, but it can really
backfire.
It can backfire.
Yeah.
And increase the cost even more.
Okay, so you mentioned also, well, actually combinations, right? So you've mentioned capacity revamping, also emission revamping and energy revamping. How do those three work together? Because I think we all see that the industry is getting under increasing pressure to reduce emissions.
Mm-hmm.
But at the same time, I think just from that perspective alone, probably the return on investment would solely rely on carbon tax, which might be beneficial, but at least at the moment it's not yet. How does this work? The combination of emission, energy and capacity?
Well, we have three types of revamp. If you want to separate them, we have the capacity revamp, the energy revamp, and emission revamp.
Okay.
Emission revamp is typically triggered by increasing norms from the governments.
Mm-hmm.
The government lowers the threshold of emissions. You will lose your license to operate, LTO we call it.
Yeah.
And then you have to do something as client. That means you have to fulfill the requirements, and there's typically no payback because typically it's only cost. So you can, of course, capture more ammonia, and ammonia safe, but never weighs up to the cost of investment if you do that.
Mm-hmm.
Second one is energy. Energy is directly linked with decarbonizations, because the less energy you use, the less carbon you use for making this energy. So it's a direct link, and that is nowadays we see really is popping up as a even standalone revamp tool to reduce the energy consumption and thereby also reduce the carbon production.
And is there a sort of probably, you're going to say every plant is different, every region is different, but is there sort of a rule of thumb to how much energy you can reduce?
Yeah, you have already given the answer. It depends on the plant. We have in our conventional plants, typically steam consumption fairly high, between 1,200 to 1,600 kg per ton of urea.
Mm-hmm.
In the 60s, 70s, we developed our stripping plants, which are already a big step forwards, and the steam consumption reduced between 800 to 1,000 kg per ton. Recently, we have sold our ultra-low energy, where the energy consumption is between 550 to 600 kg per ton of urea.
Okay.
So in principle, a revamp can mimic the latest grassroots plants and also go to 550, 600, but that requires a substantial investment on energy.
Okay.
And it's also not limited to Stamicarbon technology only. We can also do it with competing technology and reach the same figures. But it requires a substantial investment in high pressure equipment. We can also lower energy by only applying low pressure equipment, but then we cannot reach that low levels. But still interesting levels for most clients.
Okay, so if you have a, let's say, older plant, let's say older than 10 years ago, you could decrease your energy consumption per ton of urea by, well, at least 200, 300 tons of steam per ton of urea.
That's correct.
So that's substantial.
Yeah, but normally it makes, related to ROI, not really any sense because the investment level is very high. And still, because of the oil gas price, the steam cost is still low. So if you look at investment level, there's a typically payback 15, 20 years, maybe longer.
Okay.
But if you combine it with capacity, you always have to reduce the energy anyhow, then it's better to combine it with the capacity. At least you get some return of investment due to additional production.
Okay. So capacity-wise, you can increase capacity a bit or a lot. I think I've heard you say in the past from 10 till 100% capacity increase. Let's say on the low end of that range, if you would only increase capacity with 10%, but you would also want to have the energy revamp in place, let's say to pay for the return on investment, would that make sense, or would you need a larger capacity increase sort of to get to a sweet spot in the return on investment?
Oh, that's exactly why we do studies.
Okay.
If there's one solution possible, you don't have to do studies. But in studies, we investigate. And one of the terms is CAPEX-OPEX comparison. I'm not sure if people listening are aware. CAPEX is the capital investment, and OPEX are the operational expenses you have.
Mm-hmm.
Operational expenses, energy consumption, emissions, capex and investment figures and the net present value. You do the calculations there. So, coming back to this point, the OPEX can be influenced, of course, by the steam consumption, by reducing energy. But we'd like to find a sweet spot between, say, the increase of capacity and the capex you need per ton of urea, and the investment level. So, just comparison. Suppose you increase the capacity by 20%, and it costs about 10 million.
Yeah.
But you can also increase the capacity by 30%, cost you 20 million.
Yeah.
So that you already figure out 20%, 10 million.
Yeah, and we'll probably go for the 20%. Yeah.
Exactly.
Okay, so that's the options you give a client, and then based on that, I think then return on investment is calculated and the investment decision is made or not made.
Yeah, but it's not as easy as that because remember, revamp requires feedstock. Feedstock has to be available. Ammonia, CO2, water, cooling water, steam. So sometimes the client is just limited on what he has as feedstock. Otherwise, he has to increase also his feedstock. So sometimes it's as simple as the client has enough ammonia, but no CO2. So he has to get the CO2. Or vice versa, he has the CO2, but not the ammonia.
Yeah, you can always add a small-scale Stami green ammonia plant next to it, and you can add some ammonia capacity, but that's for a different podcast. So
also different capex level, I believe.
Yeah, I think so. So I think you've already described some of the difficulties for revamping, right? So it's about feedstock, it's about getting into the details, it's making sure to balance capex and opex. Are there the other things that you need to also? I think you mentioned the dependency on the, let's say, the construction party, the design and the operation of the plant needs to be aligned. Are there any other difficulties related to revamp?
Remember that a revamp, you worked with an existing plant. An existing plant has equipment designed as a grassroots to be closely together in a packed environment. So now you do the revamping. So you have to connect to an existing plant, but typically there's no room or limited room left. The equipment, the whole civil structure is built to maintain a certain weight of equipment. If you start just installing new pieces of equipment, you can imagine
it'll all come down. Yeah.
It can all come down. Like sometimes you hear flat buildings, something is added and it comes down. So that's a risk you have to mitigate. So we try to find concepts, designs. We prepare designs which is we call it add-on design, which minimize this cost. And also the downtime. Remember, an existing plant, you want to keep this in operation while doing the revamp. That means that you don't want to interfere with the existing operation. If you do a lot inside the plant environment, you have to stop the plant for a long time. And a lot of downtime means loss of money. So we have designed a lot of designs where we use add-on equipment to minimize downtime, which the tie-ins can be made during a shutdown or regular turnaround.
Okay.
And then you can put the plant easily in operation without having being limited to the turnaround time. So you construct the plant parallel to the one and you put it in operation. Also making sure you have the flexibility either to shut down the additional capacity or not. Okay,
so then you have more buttons to play with.
Flexibility to the client. So if there's a problem with the add-on unit, you just switch it off and you run down with the existing unit. A lot of clients want to limit the risk by doing so.
Okay, and I think then you can also play a bit with the amount of feed that you need depending on the capacity that you want to have an operation or not.
Yeah, you turn around your flexibility and capacity and low turn down, and the maximum capacity is also increasing.
Yeah.
But at the same time, you can also select different products in the outlet. Remember, you're making urea, but urea is not the only product you can measure. Different outlets you have UAN, you can go to DEF or AdBlue. You have a lot of different products you can make. You still have to select what you do with the downstream section.
Yeah. Okay. Well, that's very interesting. Are there any future thoughts for revamping? Where do you see the industry move from here?
I see that the number of new plants will be decreasing because of the decarbonization pressure. You see a lot of focus going to liquid ammonia currently, and we are a little bit left behind nowadays.
Okay.
But we still need food. Population is still rising, so still increasing the population. So we need still to have urea and invest With nowadays prices maybe exorbitant high. So because of the lower price of a revamp, I think most clients will be more interested in doing a revamp than building a complete new grassroots plant. Because I think most investors are not really looking to heavy investment in common fertilizer because of the carbon footprint issues.
Okay. So then, by the sounds of this, you have a very busy time ahead of you.
I have dedicated engineer working for me, so I just expand my business and hope the clients see the same point of view.
Same benefit. Well, I'm sure that everybody knows how to reach you if they want to discuss revamping in more detail.
Just send a mail to info@stamicarbon.com and we make sure it comes to the right people.
Yeah, well, that's a great way of ending the podcast. Thank you, Freddy, for your insights and contribution to this. And also thank you to all our listeners for tuning into Stamitalks. And I hope that you will do the same next time. Thank you.
Thank you for the opportunity, Mark.
Most welcome.
Bye-bye.